wanted to make a quick fun little video here. I was trying to recall what the hypergeometric distribution is all about. And I remembered it had something to do with having an urn with different colored balls in it. And the big thing here, what distinguishes it from a binomial distribution or binomial scenario, is that you don't replace the ball. So you have to think about it a bit differently. So I've got this urn and it's got 10 balls in it. 4 of them are green and 6 of them are red. And my question is, I'm going to draw a 3-ball sample out of this urn. And I want to know what is the probability that all 3 of those balls are going to be green. Okay, so without even getting into like the formula for this distribution, I'm sitting there thinking about what that probability would mean, and I think you can just use the simple sort of, or the basic probability template of looking at the number of ways that your event of interest can happen divided by the total number of events that could possibly happen in your scenario. So in this case, I'm saying I want all of the balls to be green. So how many ways could I choose 3 green balls from these 4 balls? Like, let's pretend that they were labeled 1, 2, 3, and 4. Well, that's pretty obvious. It's just 4 choose 3, or you could think of it, you could take these 3. That would be one way. You could take these 3. You could take, basically there's one that you could exclude. You could exclude each one once while choosing the other 3. So there's 4 total ways that could happen. And then in the denominator, we just want to divide by the number of ways you could possibly draw 3 balls from the 10-ball urn, which is just 10 choose 3. Okay, and we recall the formula for that: 10 factorial over 3 factorial times 10 minus 3 factorial. We get a big cancellation here. This 7 factorial will take care of most of this 10 factorial. We're just left with 10 times 9 times 8. I did a quick little division here to get rid of the 3. Popped this 3 out front, divided the 8 by 2, popped this 4 out front. Okay, and so then we've just got 4 over 120, which is equal to 1 over 30. Now you can use R to do this calculation for you, of course, and the most difficult thing to keep straight here is just what goes into what the arguments are of the d hyper function, and in what order. So in this case, I'm just asking for the density, or I guess the mass associated with drawing these 3 balls, because you could also imagine you could have asked what would be the probability of getting 2 green balls, 1 green ball, 0 green balls. So there's sort of like the sample space for this distribution is fairly small and finite, but I'm only looking at one such sample point here. Okay, so anyway, let's refresh what these are. It's just the number of successes in the sample. So in this case, there's 4. In sample is 3. In the urn, there's 4. The number of not successes or failures in the urn, the red balls, are 6, and the size of the sample is 3. So what I would do is go into R, and I would put in D hyper what did I say? 3, 4, 6, 3. Is that correct? Yes. Okay, so let's see what that gives me. And we can see that this is in good agreement with what we computed by hand. Okay, probably people are going to flip out if I don't actually show the full formula for this. how would I do this? Well, I mean, I would just have to add in a term for if the number of successes I had been less than the number in the sample. I would also have to account for the other balls in the sample that weren't successes. So let's see if I can just sort of like do like a sneaky sort of generalization of what this would mean. Okay, so this would be number of successes in the urn. We'll just call this, I'm just going to call it S urn. The number of successes in the urn, and from that we're choosing the number of successes in the sample. And then we'd have to multiply that times the sample size. This is kind of complicated. We can call this the number of failures in the sample by the number of failures the failures in the urn, choose the failures in the sample. And then all this would be divided by the sample size. Damn it. Sorry, this video got long and crappy really fast. Total number of things in the urn, choose our sample size.